Welcome to The Explainer. Today, we're diving straight into some absolutely fascinating insights compiled by Dr. Bibhudatta Sahoo from NIT Warkla. We're tackling one of the biggest, most pressing questions in the tech world right now. What does it actually mean to be a programmer in the age of AI? We're going to look at how AI and advanced automation are totally reshaping software development, the hurdles they bring, and of course, the massive new opportunities they unlock. Okay, let's dive into this, because honestly, this is the exact question keeping computer science students and even seasoned developers awake at night. Is traditional programming dead? I mean, with AI models literally generating entire blocks of complex code in seconds, there's some very real anxiety out there. You might be wondering, why on earth should I spend hundreds of hours learning the intense syntax of core languages if an AI can just spit it out for me? Are these core skills obsolete? Well, spoiler alert, absolutely not. But the role of the programmer is, for sure, evolving in a major way. So, to make sense of all this, today's explainer is broken down into 4 quick parts. First up, we'll look at the new coding landscape. Second, we're going to do a direct comparison of today's development platforms. Third, we'll uncover the hidden power of foundational programming. And finally, I'll walk you through a clear, future-proof developer learning path. Let's get into it. Part 1, the new coding landscape, defining traditional, low-code, and no-code platforms.
All right, so the bedrock of it all is traditional coding. This is your classic, highly deterministic model. You input data, you write explicit, step-by-step rules, the computer processes it, and boom, you get an output. By manually writing out logic line by line in languages like Python or C++, you have absolute total control over the architecture and the security of your app. The catch? It's highly manual and it takes a whole lot of time.
Now flip to the complete opposite end of the spectrum, and we have no-code platforms. This is an approach specifically built for non-programmers. Think business founders, marketers, designers. Instead of writing a single line of code, they use visual drag-and-drop interfaces and pre-built templates to whip up apps, websites, and workflows. Platforms like Bubble or Webflow let you prototype and launch incredibly fast. And seriously, zero programming knowledge is required. It's practically plug and play. Then, sitting perfectly right there in the middle, we have the low-code platform. Now, this approach is designed mostly for developers and IT professionals. Think of it as a massive productivity accelerator. Low-code takes those visual drag-and-drop tools from the no-code world, but lets you jump right in and write custom code whenever you hit complex logic. What this means is that professional devs can basically automate all the boring, repetitive setup tasks and focus their heavy-lifting manual code strictly on the unique features that actually make their software stand out. Let's move to the next concept and see how this builds, because software development didn't just magically jump straight to no-code overnight. It's been this fascinating evolutionary journey. Stage 1 was traditional programming, writing every algorithm from scratch. Then, developers got smart and moved to Stage 2, bundling reusable code into frameworks and APIs, things like React or Django. Stage 3 took those frameworks and wrapped them in slick visual interfaces, giving us low-code platforms. And finally, Stage 4 completely hid the underlying programming complexity to give us full no-code platforms. At every single step, we're just hiding more complexity so we can move faster.
Moving on to Part 2, comparing development platforms, the ultimate showdown.
Now, whenever you're choosing a development path, you're looking at some immediate trade-offs. Let's break down this matrix. Look at development speed, right? Traditional coding is definitely on the slower side. Low code speeds things up a lot, and no code is just lightning fast. But look at the complexity supported. Traditional coding absolutely dominates here. It handles wildly complex, highly scalable enterprise systems. Low code handles moderate to complex apps pretty well. But no code? It's pretty much limited to your basic, simple business apps. So the big takeaway here is that you are always trading flexibility and absolute control for that development speed. Which brings us to Part 3, the power of fundamentals and why core skills still absolutely matter. So the crucial point here is this. All this modern automation, it doesn't actually replace traditional programming. It just sits right on top of it. Think about it. No-code platforms are literally built using low-code platforms. And low-code platforms, they are built using traditional programming languages like C++ and Java. Traditional programming is the bedrock. It's the absolute foundation of the entire software ecosystem. You simply cannot build the tools of the future if you don't actually understand the foundation they rest upon. And honestly, this completely shatters that whole coding versus no-code myth. The future is definitely not an either-or scenario. It's a hybrid model. The most wildly successful developers out there are going to be the ones who combine the smarts of AI, the blazing speed of low-code, and the deep, secure fundamentals of traditional coding. AI and low-code tools are productivity accelerators. They aren't replacements for engineers who genuinely understand system architecture and algorithms under the hood. This is exactly why the absolute best advice for any computer science student today is to learn traditional coding first. Diving deep into a language like C++ or Java isn't just about memorizing some syntax rules. It develops your computational thinking. It forces you to master algorithms and teaches you real system design. It hones your debugging skills. Think about it. When an AI generates a huge block of code that has a subtle, hidden security flaw, or your low-code platform suddenly hits a performance wall, who fixes it? It's the developer with those rock-solid foundational problem-solving skills who knows exactly how to step in and save the day. Let's jump into Part 4, Future Developer Learning Path, your semester-by-semester blueprint. So, how do you actually put this all together? Well, in semesters 1 through 4, your focus should be entirely on building an unbreakable foundation. Seriously, no AI generation yet. Semesters 1 and 2 are all about mastering one core programming language, plus getting really comfortable with data structures and algorithms. Then, semesters 3 and 4 tackle core computer science topics, things like database management, operating systems, and full-stack web development. By the end of these first 2 years, you know exactly how software actually operates from the ground up. Once that foundation is rock solid, that is when you hit the gas. In semester 5, you start integrating AI tools and cloud computing, learning how to deploy stuff on AWS. Semester 6 shifts to industry integration, learning DevOps, doing internships, and figuring out how to work within professional teams. Semester 7 is your time to specialize. Dive deep into really hot fields like generative AI or cybersecurity. And finally, semester 8 brings the whole shebang together with major real-world projects and serious career readiness. And this brilliantly illustrates the ultimate formula to thrive. The future developer equals programming fundamentals, plus AI tools, plus low-code skills, plus cloud deployment, all backed by real projects. Notice how traditional coding isn't being pushed out by AI here. It's literally the very first pillar that makes leveraging AI and low-code platforms even possible. Mastering the specific stack is what turns you from a basic scriptwriter into a full-stack, future-proof innovator. Because at the end of the day, your goal isn't just to be a basic coder. In the AI era, the future really belongs to those who design intelligent, secure, scalable, and human-centric solutions. You're basically evolving into a solution architect. You become a technology strategist who understands the core business goals, evaluates cloud infrastructure, ensures tight security, and then seamlessly integrates AI-driven innovation to solve massive, real-world problems. Which leaves us with one final, absolutely vital question as we navigate this crazy new era. Will you try to compete with AI, clinging to the old ways of doing things, or will you collaborate with it to build the future? The tools we have today have literally never been more powerful, but they still desperately need a master architect to wield them. Thank you so much for joining me on this explainer, and I really hope this roadmap inspires you to start building that unbreakable foundation today.